Here's Precalculus Concept 27C underneath graphs of sine and cosine. We're going to understand phase shift for y equals sine x, and there's 4 boxes, so here we go. Box number 1 is understanding what the heck phase shift even is, and phase shift is basically how much, and it's usually measured in radians, the graph moves left or right. So we're talking about left and right movements. This is called phase shift. Okay, so again, I have 2 graphs for you. I have the red graph, which is your basic sine graph, and I will remind you of the 5 points. We have 0, 0, we have pi over 2, 1, we have pi 0, we have 3 pi over 2, negative 1, and we have 2 pi. And that graph has not moved whatsoever. The blue graph, however, is the graph of y equals the sine of x plus pi over 2. So I want you to take very, very special note of the x plus pi over 2 inside the parentheses. What do you think that does? Well, obviously to the graph, it moves the graph pi over 2 units to the left. It is the opposite direction you think it would be, just like it is for moving parabolas left and right, and rational functions left and right, and every other function that we've talked about in class. So basically, check this out. Each of my dots has moved a value of pi over 2 radians to the left. So this has become here. This dot has gone pi over 2 to the left. This dot has gone pi over 2 to the left. And this one has gone pi over 2 to the left to give us this nice, new, pretty blue sketch of x, the sine of x, plus pi over 2. So that's what I'm talking about when I say phase shift. We're talking about moving the graph left or right. Okay, I want you to take this information, and what I want you to do is I want you to give me a guess. What do you think the phase shift is going to be in the equation y equals the sine of x minus pi over 4? Okay, hopefully you got the answer of pi over 4 radians to the right. So here is the picture again. The red graph, of course, is your basic sine of x graph with your 5 points highlighted. And the blue graph represents the y equals sine of x minus pi over 4. So notice that each dot has moved pi over 4 units to the right to create that blue, nice, new, pretty sine graph. Nice job, you guys. Okay, box number 2. Let's determine the phase shift for y equals the sine of x plus pi. And then we're going to compare that with a sketch of y equals sine of x. Okay, so since we are dealing with adding or subtracting a certain amount inside the parentheses, we know that the phase shift is going to be pi units to the left because I am adding pi units. So therefore, I'm going to make a coordinate plane here, and I'm going to give myself both some space on the left and on the right. So I'd start with 0, I would start with pi over 2, I would start with pi, and then 3 pi over 2, and then of course 2 pi. And then if I went backwards, I'd have negative pi over 2, and then negative pi, okay? And obviously I go up to 1, I go down to negative 1. So for my red graph, I will graph the sine of x, the basic one. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi. So there's a nice, quick, easy sketch for y equals sine x. And then my blue graph, I will graph y equals the sine of x plus pi. So that means that each dot gets moved pi radians to the left. So this dot ends up being here. 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 And this dot ends up being here. So notice that each one has gone a distance of pi radians to the left. And you end up with this awesome, beautiful graph. Yay! Okay, here's your time to shine. Tell me the phase shift and tell me the direction. So tell me the amount in radians and say either left or right. Okay, hopefully you said the right answer of pi over 7 units to the left because I am adding pi over 7 units inside my parentheses for my sine function. Okay, box number 4 is a warning example. Warning example here. If I asked you for the phase shift for example A, many people would say it would be pi units to the left. And they would be wrong. And then over here in in part B, people would say, oh, that's pi over 2 to the right. And you can see why they would say that. But are you noticing that there is this extra number here inside the parentheses that's throwing everything off? So what you got to do is you got to factor that out first. So what I mean by that is you should factor this into sine of 2 times x plus, now watch this. This becomes pi over 2. What? How is that possible? Here's why. Because when I multiply 2 times x, I get a value of 2x. When I multiply 2 times pi over 2, I get back a value of pi. So what I've done is created an equivalence statement. So you must factor out that 2 and put in the appropriate factor. So the true phase shift here for this one, ladies and gentlemen, is pi over 2 to the left. Yes. Okay, watch over here. This one, I would say, this is equal to y equals the sine of 2 times x minus pi over 4. Why is that true? Because 2 times x gives me back 2x, and 2 times the quantity of pi over 4 is pi over 2. So therefore, the phase shift would be pi over 4 to the right, because I have a minus sign there, so I go the opposite direction. So there's a warning right there, so be very, very careful with that. Okay, see you guys tomorrow.